In this video, I want to showcase a method for performing matrix multiplication in Power Query. And what is matrix multiplication? Well, I'm not a mathematician, but I found a picture here from this guy, Greek data guy, which shows what you want to do. You have two tables. You need the left or X table to have the same number of columns as the right or Y table has rows. You'll grab all the values from the columns of a given row of the X table and multiply that by all the rows of a given column in the Y table. And that's quite a mouthful, but we can see the intermediate steps here. In cell A1, that is the first column and the first row, we want to take the first value and multiply that with the first value, which is 1 by 10, and then second value multiplied by second value is 2 by 20, third value by third value, and then we do the calculation. In other words, we sum the product, and then we end up with 140. And you'll see that this is a 2-row 3-column table and a 3-row 2-column table, where we end up with a 2-row 2-column table, because the number of rows is then equal to the number of rows of the left table, and the number of columns is equal to the number of columns of the right table. Again, it's quite a mouthful. The two tables I'll be using in Power Query are these two, the X table, and what helps me is to call it X because we care about the rows, and then the Y table because we care about the columns. And then when we want to perform the calculation, as the picture shows, we say value 1 times value 1 plus value 2 times value 2 and so on. We don't want to do that manually. What we can do is to use the sum product function. I'm in Excel 2016 and not later versions, which is important because I don't have access to array functions. But you should if you have Excel 2021 or later. Here I've taken the first row and converted that into the array by selecting the values. Then we can see the highlighted here. Then I press F9 to convert them into values. But then we don't have the references, which we kind of want. Problem with Excel 2016 is that the first problem we have to solve is explained here. Our rows are arrays that use slashes, columns are arrays that use semicolons. If we look here, the A4 to D4, we use slashes because it's a row. For the column, we have semicolons, and we need them to be the same kind. It doesn't matter which kind we use, they just have to be the same. And we can solve that by using the transpose function. But then we have another problem, because I'm in Excel 2016, which is that I can't do an array function normally. If I try to do that, I'll get a value error, and it's not super helpful. What happens is that I am taking an array and multiplying that with a different array, and then it's supposed to output one value, but Excel is a little silly, so I have to hold down Ctrl Shift and press Enter, and then it calculates. And then I can do that for all the other cells, and then when we do that math, we end up with this table, where we can see I've made fixed references in order to be able to copy the function. In other words, these are two input tables, and this is our desired output. And I found it's a good idea to have the desired output when you evaluate the code, because it's a doozy. But we can now move on to our code in Power Query. In this first video, I'm going to make the easy version, which is that in cell A1, I'm going to create a list that contains the X lookup and the Y lookup, which means in this first cell, the lookup is going to be 1, 1. In the second, it's going to be 1, 2, because I want the first row of the X table and the second column of the Y table. Then we do the lookup into the X and Y table to grab those values, and then we do the calculation. I ultimately want this to be a function, which I'll do in the second video. Because we're making a function, it's a good idea to start with a helper query, but our inputs are tables, and when we go into parameters, we can't add a parameter that's a table. We can only take a singular scalar value, which means we can't create the query and then right-click, convert it into a function. That isn't possible because our inputs are tables. What I like to do when I want to do that is I want this function to have two inputs, the X and the Y table. I like making my first two steps be then the names that I want to give the variables. I want my function to take an X and a Y value as an input, so I will name my first two steps X and Y, and then it's a lot easier to change the code. And I can change the name of this second step, but I can't change the first step. But I can do it if I go into Advanced Editor. And now we're ready. First want to check that the dimensions are proper, because we need the number of columns in the X table to equal the number of rows of the Y table. We will perform that check, and we'll reference this in the last step of our function. I like doing this check whether you should continue as early as possible, even though we only reference it at the end, because Power Query is lazy, so it doesn't actually care where you place it. Mentioned, we want to count the number of columns of the X table, and we want to check if this is equal to the row count of the Y table, and that is true. So we continue. We can also figure out what the final size should be by checking what the row count of the X table is going to be, or the column count of the Y table. It doesn't matter, because it's going to be an evenly sized square, so 2 by 2 or 3 by 3. And then I want to convert this table into a one column table with lists, because every time we access the X table, we actually access the entire row, which means I want to contract this table into one column, where in the first cell, I have the list of all of my columns. So 1, 2, 3, 4 in this first value, then 2, 3, 4, 5, and that will make things a lot easier. I want to do the same thing for the Y table, but I care about the rows instead, which means we have to take value 5, 6, 7, 8 and output that in this first cell. And that is slightly more difficult, but we can solve it. I will call this X to one column, and then we are going to combine the columns. I want to see the X table, because then we can see it contract. I want to combine the columns of the X table, and then I want my source columns to be the column names of the X table. And then my operation, my combiner, is I want to output the values themselves, because these are numbers, not text. And normally table.combine columns likes to output text, but I need it to be numbers. And then finally, I'm going to call the resulting column A, because we'll be referencing this later. Now we have our lists. As I said, we want to do the same thing to the Y table, but we don't want to have one column of multiple rows. We need to have one row with multiple columns. And we could turn that into a record, but I'd like to have tables, because I think that makes it easier, because we're doing matrix multiplication, which is acting on table 1 and acting on table 2. This is slightly more complicated. As mentioned, I want to start by creating a list of functions. I want to use list accumulate. I want to grab the column names of the Y column, because I want to iterate over each column. And then I start with an empty list. And my function, as always, is state comma current goes towards. I want to output the state, and then I need a list of lists, and this will make sense in a moment. And then I want table.column, and this, if it wants to cooperate, column there, because I need to access the column using a text, which we can do here, column as text. I can't use the square bracket syntax, because I am grabbing the column name from my list, which is then the current keyword. And if I wrote current here, it would literally try to find a column with the name current. We can't do that. I go into the Y table, and I extract the column with the name of current, that is my current keyword. And then I check my parentheses, and that looks fine. Going to make sense in a moment, I promise. And then we want to transform our column. The trippy part is that we need to contract the table into a one row table, which Power Query isn't really designed to do. So what we could do is to transform the entire column and say that cell A1 has the list 5, 6, 7, 8, and the second row also has those values, and the third row has the same values, and so on. But we only care about the first row. So that's what we're going to do. We are going to start by extracting the first n rows. We're not going to use the first function because it outputs a record. We need a row, or rather I want a row. We go into the Y table and extract the first row, which means we now only have the first row. And then actually we can do no transformation, and then we end up with what we expect, a one row table. But then what I want to output is then the table.transform columns function. In the transform operations, we can output a list of lists, where the inner list the individual transformations. So instead of writing, go into the A column, perform a transformation, go into the B column, perform a transformation, and so on, we would have to hardcode that. Instead, func list outputs our list of functions, and we can actually output that. Copy this, and then I want to delete that and say func list. We get here a list of lists, where we see we have the name A, the column name, and a function. You can click on that and see the function. It doesn't explain what it does, so we have to look at it. If we go back, I just want to output the function first. And actually, because we wrapped it here in a list of lists, everything is fine. So now we end up with the list. If we look at the function, it creates a list with one item per column in our original Y table. And that value is then to grab all of the values in the column. And if we take a look at what that does, we'll say we go into the A column. It outputs a list, which is what we want. So it's a very convenient function. And then again, we have to wrap it in a list of lists in order to get the correct format for table.transform columns. And now we have what we want. We have one column with all of the X values and one row with all of the Y values. Then we have to multiply the two together. And as mentioned in this first video, we're going to do that by creating a lookup table, which would have 1, 1, 1, 2, 1, 3, and so on. And this is mostly for illustration purposes, because it does make things a ton easier. And this next part might not make a super lot of sense. I apologize, but what we want to do is to create a table, which actually I'm going to create a list of lists, which is a nightmare, but we need that to create a table using the table.fromColumns function. And that will make sense in a moment because we'll look at the individual lists once the function is done. And we have to start from row 0 to final size -1 because we're creating a list and we're creating a list lookup, and lists are index 0 based. So we do that -1, and then we do the same thing for the columns, also 0 to final size -1. We want to use that in. In this case, we have 3 rows and 3 columns, so we'll be creating a 3x3 table. But again, I want to create something that's variable and can become a function in the next video. What we want to do is then to accumulate over either the rows or columns, and it doesn't really matter which. I'm going to use columns. We start with an empty list. Our function is then state, current. Actually should probably call that column state and column current. And then this is going to go, we want to output the state. In other words, the result of our previous operation. We want to create a list, which is then going to use the list.zip function, which is then going to take another list, which is then another accumulation. We now want to loop over the rows list. And again, we start with an empty list. And again, we have a function, which will then be row state, row current. And now I really need to pay attention. We're going to output the row state and a list of, then want to output a list, which is going to be the row current. I'm going to be very impressed if I do this without messing up. And then we need to end the list and the parentheses. So this was the first list inside our list.zip because we need the X positions. And then here I need to use list repeat because we need to repeat the columns. That is then a list that we repeat. So we need to output the column current as a list, which would then be the value 0 in the first iteration, but as a list. And then how many times to repeat it? Well, the final size, in this case 3. And then I have so many parentheses. I think this should be it. No, we're gonna do some indentation. I am missing a parenthesis somewhere. Okay, just because it outputs something doesn't mean that's true. We will take a look. We get 3 rows as expected. We look at the first one. We get a list of 0, 0, 1, 0 actually, and 2, 0. And then likewise in the third, we're going to get 0, 2, 1, 2, 2, 2. And we can then convert this into a table because we now have a list of lists of lists. And that's because our table.fromColumns function takes a list of lists. But then the innermost list is because we want our table to output a list. So instead of having one value in A1, we want to have a list of 2 values. We can then use table from columns. You go into custom 1, and I should change the name of that. And we want to grab the column names from the Y table. And then we get 0, 0, 1, 0. We want the second row of the X table, first column of the Y table. And we can rename them to be lookup table list, and then lookup table. And now we can then do the actual lookups, which means we want to replace this list of 0, 0 with then this 0 should be the lookup in the X table, and this 0 should be the Y table. So actually, if we take this second row, we want the second row of the X table and the first column of the Y table, which are then lists themselves, so it becomes a mess again. But we can then do the lookup, which is then another mess of list accumulate. Again, I don't expect to write this correctly the first time. We want to grab the column names, which is then column names of actually the Y. I want to grab the previous step because this is the table we're acting upon. I think that makes it make more sense chronologically, I guess. Next, we want a list of transforms, which again, actually I should call that func list. That's what we used previously, which is then list accumulate. Our list is 0 to final size -1. My seed is an empty list. My function, as always, is state, current, goes towards, and I want to split that in a new line. And then this is going to output the state and a list. This is similar to what we did here with the transform columns, where we want to output a list of lists because the table.transform columns function takes a list of lists. And now it's mad, so we're going to say, I want to look into previous step just because I think that's prettier to look at. This is what we're operating on. So I need to output a list of lists where the inner list takes the column names, which is then, we can use the current to do this lookup. And then our actual operation is because we have a list of values where we want the first value to be one lookup and the second value to be a second. We need to output a list. Yeah, we need to output a list. So curly brackets. We want to do a lookup into the X table, X to one column. We are accessing the A column, which is hard-coded because we make sure it's called A. And then we want to access, go into the current row, which is then the each, which is then the current row here, which is then this list. And then we want to access the 0th position to get the X value. And then we want the same lookup. Actually, that needs to be in, no, not there, in here. The second lookup is then go into the column. And again, we need the table.column function because we are inputting the column name as a text. So our table is the y to one row, and our column name is going to the column names, so it's lookup. And then we have a mess of parentheses. Yeah, we are accessing the current row, which again is this list. We're accessing the first item, which is actually the second. And then this gives us the whole column, where we then want to access the 0th row, because there is only one row. Again, index 0, because we're doing a list lookup. And then we have a lot of parentheses. But actually that should be it if I wrote it correctly, which I didn't. Actually I did, but I'm not outputting anything. So we can now do the transform table, transform columns. We go into the previous step, which was lookup table, table. Then we want to insert our func list as our transformation. And that's actually everything if I wrote it correctly. We're going to add some indentation. That usually helps. At least it helps me. And that is because this is not parentheses. This is an index lookup. So we wrap that in a list. And then we get that list of lists. So we'll output list. That gives 3, 4, 5, 6, which is the third row of the X table. And this was the first column. So we want 5, 6, 7, 8, which is 5, 6, 7, 8. Yeah, so that is what we expect. But we're still not done because we now have our lists, but we now need to do the actual sum product, which I was a bit surprised that there's no sum product function, at least not what I can find. There's this list product that multiplies all the values in the list, and that's not what we want. We have two separate lists, and we want to multiply the first item in the first table with the first item of the second table, take that sum, add that to the multiplication of the second values, third, and so on. And this just takes all of the values and multiplies them, which means we need to create a function which we're going to make in a new query. And this will take a list. Because if we go back in and look at this element, we need to take this list and multiply it with this list, one element at a time. And conveniently, that's actually the intended use of list accumulate. You are accumulating over a list, performing some operation and adding that to the state or the cumulative sum, meaning we're finally actually using the function the way it's designed. So func sum product. As said, we need list A and list B. Want to buff the list. We could probably have used buffs earlier. I imagine that would help. We're gonna ignore that. And then we want to use those in. We want to accumulate over a list of 0 to the number of items in one of the lists. And we want to say -1 because index 0 based. Our state is 0 and our function is state, current goes towards our state, which is then the cumulative sum. And then we want to add, do a lookup into buff A using the current, multiply that value with a lookup into the B list. And then we get our function. And now we can transform the tables once again, which means we need this structure again. I'm going to copy that and call that sum product. And then we need to make sure to update this table reference. I do need the column names because I'm acting on each column. And then we can delete this part and make sure to update that reference. Then our operation is again list accumulate. We need one list per column, which again starts from 0 until the number of columns, which is final size -1. Our state is an empty list, and our function, as always, is state, current, which is to take the state previous list's transformation. Then we need a list of lists. We will look up into column names using current, grab the current column's name. That's the one we're acting upon. Our function is then to use the func sum product upon, grab the value in the first item and grab the value of the second item. And yeah, and once again, it's because I think I need to use parentheses here, but I need to do a list lookup. And then if we go back to Excel, we can see this is actually what I expect, 70, 80, 90, blah, 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 blah. So it certainly works. And then we still finally actually need to add that check size condition to say that if check size is equal to true, then sum product, else improper dimensions. We can then go and change the check size. In this case, it's a bit easier to remove rows. We'll go into the Y table, check the first n, grab 3. We then get a text output, improper dimensions. And then we can do the same thing for the X table, where we remove a column. Easiest way is to use the projection operator, the double square bracket syntax. So then like this. Now we also get improper dimensions, but one thing we haven't checked is that what if we only have, if you have fewer rows in the X table and fewer columns in the Y table, let's say first n, comma 2, then we get an error here where the number of columns don't match. Go in, actually that might be a bit difficult to evaluate. We're going to do that, and then we can say, well, now we get a list of lists, 0, 0, 1, 0, and then this would be 0, 1, 1, 1, and that I imagine is because now the table.column names of Y don't match. So what we could do is something like, if we say we actually don't want to grab all of them, because now we have to grab table.column names not from Y, we have to grab as many column names as there are rows in the X table. Again, I'm not a mathematician. Oh, I don't actually know what a matrix multiplication is, but I thought it was fun. We want to say list first n, and then grab the row count of the X table. And then that should be A and B. Then I sure hope that is what I need to do. That was here. We can add a comment. And then that should be fine. And then we delete these. Yeah, because as I mentioned all the way at the start, we're going to end up with a table that has, I think it's rows equal to the X table and columns. Actually, no, it's going to be like a square, which I can't highlight here, meaning because the X table has 2 rows, it's going to end up with 2 columns. Because again, you multiply X 1 row at a time, and you only have 2 rows, so you only care about 2 columns. I'm not a mathematician, but that should be it, yeah. But I think that's as good of a solution I can make with not being a mathematician. So next video, we'll turn this into a function, which is going to be a little difficult, but it'll be fine. So